Our next number was the mighty vectors, the question which I almost want every student to handle if we understood properly how we interpret ratios. If you have not, please first go to the playlist and then you see how we do ratio interpretation in vectors. Okay, to start with, you can pause the video, you can read you can see the question there at the start of the video, the whole question. So let's start it with it here. It says, in the diagram below, they gave us xy as that, and then they gave us these ratios as you see them. Point Q is on XR such that XQ equals 2QR. Then they give us this diagram. The first thing they tell us, find in terms of X and Y, the vectors, those ones. Now what we do before you handle any vector, you have to first put the ratios the way they are supposed to be. Now you come to the ratios. First of all, I have XP, Y to PY. XP to PY. I think that XP is taking 1, then PY takes 2. That is the easiest. Then I come to YR, where's YR? 2. YZ. So meaning YZ is the big line, is having 4, YR is having 3. So YR has 3, the whole of YZ has 4. Meaning if YZ has 4 and this is 3, this one takes a balance of 1. Then this one sits mixed. So you first now, always better is first separate and you put these figures one side and then the letters also one side. So this will be now XQ, you divide by QR equals 2 over 1. So that XQ to QR equals 2 to 1. So my XQ is 2, QR is 1. So now I've interpreted all the ratios. So now I'm free to start. They're telling me first of all, find YZ. Now my remaining one, they want me to get YZ. YZ will be, I'm not going to put the symbols because we know that they are supposed to be vectors. YZ, so that my YZ is going to be from the first, from Y, you use alternative roots. YX is going to be YX plus, it's going to be YX plus XZ. But if you are doing this, you make sure that you have not changed any direction. We had XY going this side, but we are now getting YX. So we have changed the direction. You show that we have changed the direction by putting the negative of the original, which is XY. Then plus XZ. This is negative XY was given as X. Then plus our XZ, which was given as Y, which you can write as Y minus X. You can put the vector symbols there. Okay, we come to our next one, which is XR. Remind me of 2. They want us to get XR. Our XR, you come to the diagram, XR is here. So it's better I move XY plus YR, or someone can move XZ plus ZR. But it's always better you maintain the direction of this first vector you obtained, the YZ. So this root of YR is better. So that's how I'm going to say now. X is the starting, so XY plus YR. The X first, the R last. So now, my XY, I've not changed any direction, so it remains there. So XY plus my YR. My YR is the segment on this. So YR is having a ratio of 3 over the total ratio, which is 4 of the line YZ. As simple as that. So now we'll do the substitutions. This one is X plus 3 over 4 into, now my YZ, which is Y minus X. The LCM there is going to be 4. 1 goes here 4 times to get 4x, or you can easily simply cross multiply, plus 3y minus 3x, which you can ably simplify. This will be 1/4 4x minus 3x, you get x plus 3y. That is my XR with is. And I come to the next one, I want them to get PZ. So Roman numeral 2, our PZ. Okay, our PZ. Our PZ, you look at the PZ, I can move PY plus YZ because someone can say PX plus XZ. But because I am changing the direction, I don't opt for that route. So my PZ, PY plus YZ. My PY. You see that PY is a segment, so it's 2 out of 3 of the whole thing, XY, of XY plus YZ, which I have already. Substituting now there, this will give us 2 over 3. This is X plus YZ. Our YZ is here, Y minus X. Get our LCM, which is 3. 3 goes there to get now 2x plus now 1 goes there 3 times 3 into y minus x, which we can ably simplify to 2x so which we can get as 1/3 into, now we have 3y minus 2x minus 3x, get the x there. So this is now my PZ. Okay, so this is Roman numeral 3. Roman numeral 3. Then when we come to part B, show that, part B, the show that P, Q and Z are collinear. So what you do, you have to just get the any two segment and any two. So what I'm going to do, I have PZ already, so I'm going to get PZ, and this more easier one, I can get either PQ or QZ, any, but I think I can get PQZ according to I can get PZ and PQ. So PQ, I have PZ already, so I get now PQ. My PQ is going to be from here. My PQ is going to be PX plus XQ. So PX plus XQ. P first, Q last. So my PX, you start PX, I'm changing the direction, so it's going to be negative. You see I'm opposing this direction. So negative is a segment 1 out of, the total is 3 of X, Y, then plus XQ is also a segment which is 2 out of 3 of which line is a segment on XR, which will be negative 1/3. XY is X plus 2 over 3 into, now XR, I think I have XR here, which is 1 over 4 into X plus 3Y. The LCM is going to be 12. 3 goes here 4 times to get now negative 4x plus 12 goes here 1 times 2 times this to get 2 into x plus 3y, which I can ably open brackets to get now minus 4x plus 6y, the whole thing over 12, which will get me to negative 2x plus 6y over 12, which I can divide through by 2. I'll get now negative x plus 3y over 4. This will give me 1 over 4 into 3y minus x. This is now my PQ. Now, so that they are collinear, I have to get a ratio between these two. So my ratio, I can say now PQ or PZ over PQ. As long as we get the ratio, they are collinear. Our PZ was a third into 3y minus x over a quarter into 3y minus x. As long as these two can cancel, you see that I have 1 over 3 divided by 1 over 4, which will be 1 over 3 times 1 over 3 times 4. That will be very easy that way. So now my PZ over PQ is equal to 4 over 3. So meaning PZ to PQ equals 4 to 3. Meaning, as long as I have that, as long as I can get a ratio between the segments, it means that I have the line, the points are collinear. So now you can conclude the coordinate that since P, Q and Z, or we can say since, there are many ways to conclude. So depending on, you can also conclude that since, you can say that 3 PZ equals 4 PQ with P as a common point, then P, Q and Z are on straight line. Okay, that's it. If you want some more questions about vectors, you can visit the playlist. They are well explained. That's it. I wish you well. Let us go to number 15.